Hey, what's going on everybody? Today I'm going to talk about static methods in Python. A static method is a method that belongs to a class rather than any object from that class, any instance. Instance methods, we're already familiar with them. They are methods that belong to individual objects created from that class. They're best for operations on instances of that class, any objects. Whereas static methods, they're best for utility functions within a class that do not need access to class data. I'll demonstrate the differences between an instance method and a static method. We'll begin by creating a class of employee. We'll need a constructor. Let's define that. To create an employee object, we'll need a name and a job position. We will assign self.name equals name, self.position equals position. We will create an instance method of getInfo. We will return employee info. We will return an f string where we will display self.name equals self.position. GetInfo is an instance method. Each object that we create from this class will have their own getInfo method to return the information on that object, the object's name and the object's position. Now we'll create a static method. To create a static method, we need a decorator of static method. Static methods are best for general utility functions within a class. We'll define a method to check to see if a job, a position, is valid, which we will name isValidPosition. So static methods, they don't have self as the first argument. We're not working with any objects created from this class. To check to see if a position is valid, we will pass in a job position, which I will name as position. I will create a list of valid positions. Let's assume that our company is the Krusty Krab. What are some valid positions? A manager is a valid position, a cashier, a cook, then let's say a janitor. Then we will return, we'll use a membership operator. Check if position that we receive is in our list of valid positions. What we have done is that we have created a static method. We don't need to rely on any objects to use this method. For example, to use a static method, we will use the name of the class, rather than any object that we create from this class, such as this. We don't need to do that. We type the class name, followed by the static method, isValidPosition. Then I did set this up to accept one argument. Let's check to see if a cook is a valid position. Then I do need to print this. What is the output? A cook is a valid position. What about a rocket scientist? That would probably be Sandy's job. That is false. A rocket scientist is not a valid position at the Krusty Krab. This is a static method. It belongs to the class, not any object created from that class. Now let's create a few employee objects. Let's say employee1 equals a new employee. We have to pass in a name and a job. Eugene will be the first name. That's Mr. Krabs. He will be a manager. Employee2 equals employee. Squidward will be a cashier. Employee3 equals employee. Employee3 will be SpongeBob. SpongeBob will be a cook. To call an instance method, we have to access one of the instances of the class in order to use it. If I want to check the info on employee1, I will access that object, that instance, use the getInfo method, Then I need to print it. Take employee 1, get the info. Eugene is the manager. Let's do this with employee 2 and employee 3. Eugene, Mr. Krabs, is the manager. Squidward is the cashier. SpongeBob is the cook. For an instance method, you access an object, then call the instance method. With a static method, you only need to access that class. You don't even need to create any objects from that class. It's a general utility method. Alright everybody, those are static methods. They're a method that belongs to a class, rather than any objects created from that class. They're usually used for general utility functions that do not need access to class data. And well everybody, those are static methods in Python. Hey, what's going on people? So today I gotta talk about class methods in Python. A class method allows operations related to the class itself. They take CLS as the first parameter, whereas instance methods will take self. Self refers to any object created from that class. CLS, meaning class, refers to the class, not any objects. Here's an example. We will create a class of student. We'll need a constructor to construct some student objects. All students will have a name and a GPA. Self.name equals name. Self.gpa equals GPA. We will also create a class variable for this demonstration of count. We will count how many students we create. Whenever we construct a student object, we will access the class of student, take our count variable, increment it by 1. Whenever we create a student object, increase count by 1. I will create an instance method of getInfo. Instance methods have self as the first parameter. We're referring to the object we're currently working with. I will return an F string where we will display the student's name and their GPA. Self.name, self.gpa. I'll add a comment that this is an instance method. Now to create a class method, to work with class data, we will declare a class method with a class method decorator. Class method. What we're going to do is define a method to get the count, the class variable of count. This method will be called getCount. Rather than self as the first parameter, we'll be working with a class, CLS, meaning class. I will return an F string, total number of students, add a placeholder, CLS count. Let's test this. To call a class method, you take the name of the class, followed by the class method, getCount. And then we do need to print this. What is the count of my current students? Total number of students is 0. Let's create a few student objects. We will create student1 equals, call the student constructor. We have to pass in a name and a GPA. Let's say that the name is SpongeBob. SpongeBob has a GPA of 3.2. We'll create 2 more students. Student 2, student 3. Student 2 will be Patrick. Patrick has a 2.0. Then Sandy. Sandy's smart. In fact, she's a genius. She has a perfect 4.0. Now let's count the number of students. Total number of students is 3. When we call this class method, we can access or modify class data, this class variable of count. Rather than using self, we use CLS for the class. Let's create one more class method. This time I'll calculate the total GPA of all my students. We'll need a class variable to hold that data. Let's say total GPA equals 0. Whenever we construct a student object, we will access our class of student, get the total GPA, then add plus equals this student's GPA that we have just created. Basically speaking, the total GPA, this variable, is going to accumulate all of the GPA of every student and store it as a sum. To find the average, we're going to divide it by the count, the number of students. We'll do that within a class method. To create a class method again, we need to use the class method decorator. I will define a method of getAverageGPA. The first parameter is CLS for class. I will check if CLS count, the count variable of my class, is equal to 0. That means if we have no students. If that's the case, if there's no students, we're going to return 0. Because otherwise we're going to divide by 0 and we'll get an error. Else we're going to return an F string. Follow this formula. We're going to take the total GPA of my class.totalGPA, divided by class.count, the number of students we have. That's how to calculate the average GPA. After getting the count of the number of students, to access a class method, we take the name of the class, student, call the class method, getAverageGPA. Then I will print it. Total number of students is 3. The average GPA is 3.06 repeating. After calculating the average, I'm going to add a format specifier of 0.2f, just around to 2 decimal places. And I'll add average GPA : space, then we'll calculate the average. Alright everybody, those are class methods. Instance methods are best for operations on instances of the class, any objects. Static methods are best for general utility functions, which do not need access to class data. Class methods are best used when we're working with class-level data or we require access to the class itself, such as when we're working with class variables. Rather than using self as the first parameter, we're going to use CLS, meaning class. And well everybody, those are class methods in Python. Yo, what's going on people? So today I'm going to explain magic methods in Python. Magic methods are also known as dunder methods, meaning double underscore. You typically find these within classes. We're already familiar with one of them, our dunder init method. We have double underscores on the left and double underscores on the right. But there are others. I'll cover a few of the more beginner-friendly ones. So what these methods do is that they're automatically called by using some of Python's built-in operations, such as printing an object, seeing if two objects are equal, greater than or less than. When we use many of Python's built-in operations with objects, we can define and customize the behavior of those objects. So in this demonstration, I'm going to create a class of book. We will construct some book objects. We will define a magic method, a dunder method, of init to initialize these objects. For a book, we need a title, an author, and the number of pages. We'll say num pages. Self.title equals title. Self.author equals author. Self.number of pages equals number of pages. When we call the class of book, we are automatically calling dunder init. So let's create a book object. Book1 equals book. We need a title, an author, and number of pages. So since we're dealing with this topic of magic methods, I'll pick some fantasy-related books. For my first book, I'll pick The Hobbit. That's the title. The author is J.R.R. Tolkien. The number of pages is 310. So for my next book, book 2, I will pick Harry Potter and the Philosopher's Stone. The author is J.K. Rowling. The number of pages is 223. Then we have book 3. For my third book, I will pick The Lion, The Witch, and The Wardrobe. The author is C.S. Lewis. The number of pages is 172. Okay, here are my 3 book objects. When we call the class of book and pass in arguments, we will call the dunder init method. It's a magic method. It's automatically called behind the scenes. Within this magic method, we can define and customize the behavior of objects. And in this example, we're just assigning the attributes of title, author, and number of pages. That is one built-in operation of Python. What would happen if I was to print book 1 directly to the console? Here's what happens. Well, we're given a memory address. Here's book 2 and book 3. Well, we can customize this behavior. We will use the dunder string method. Double underscore, str meaning string, double underscore again. We have one parameter of self. Instead of returning a memory address, we can customize this behavior. Let's instead return an f string. I'll add 2 placeholders. We will display self.title, the title of the book, by self.author. And I'll place the title within single quotes. Now let's print book 1. We have The Hobbit by J.R.R. Tolkien. Let's print book 2. Harry Potter and the Philosopher's Stone by J.K. Rowling. And book 3. The Lion, the Witch, and the Wardrobe by C.S. Lewis. So that is dunder string. We can return a string representation of the object when we print it directly to the console. Here's another dunder method. We can check to see if 2 objects are equal. I will print is book 1 equal to book 2. That gives me false. If they were to have the same title, the same author, and the same number of pages, then Python would say they're not equal still. So let's customize this behavior. We will define a method of dunder equals, which is just EQ. For parameters, we have self, the first book we're examining, in this case book 1, and other. Other means the other book. We're examining 2 objects for equality. To do that, we'll see if the title of 2 books and the author is the same. We'll disregard the number of pages. You can have 2 different versions of the same book. They might have different font sizes, or the dimensions of the physical pages might be different. So we will return a Boolean value. We will examine if self, that's the first book, is the title attribute equal to our other book's title, and is the author of the first book, self.author, equal to our other book's author. If I were to run this, we get false. Book 1 does not equal book 2, but if they have the same title, I'm going to replace these, and the same author, then they would be equal. And we'll disregard the number of pages. Let's say that with this version of The Hobbit, they're using a smaller font size, so there's less pages. We're using dunder equals to compare if 2 objects are equal. What if I was to print book 2 is less than book 3? Like, what does that even mean? And I'm just going to get rid of these 2 lines. Type error, less than is not supported between instances of book and book. So we can't use less than on 2 objects. But we can customize that behavior by using dunder less than, which is just LT. We're examining one book and the other book. Self and other. Let's compare the number of pages. We'll compare if the pages of book 2 is less than book 3. We will return a Boolean value. Is self.number of pages less than other.number of pages? So now, this should not give us an error. Book 2 does not have less pages than Book 3. Another would be greater than. I'll just copy what we have. Dunder GT for greater than. For our first book of self, is it greater than the number of pages of the other book? Well, that's true. The number of pages of Book 2 is greater than Book 3. Let's use dunder add to add the pages of two books together. What would happen if I were to add two books together? Book 2 plus Book 3. Well, we get a type error. Unsupported operand for book and book. Well, to customize the behavior of addition, we will define dunder add. We have self and other for the other object. Let's add the pages together of two books. Maybe we need a summer reading list, and we would like to see what the total number of pages is. I will return self.number of pages attribute plus our other book's number of pages. That would give me 395. That's 223 plus 172. Heck, I'll even put this within an F string. 'Cause why not? Then I will add the word pages. 395 pages. Within an object, we can search for a keyword within one of the attributes. So let's find the word lion within Book 3. To do that, I would write a statement like this. Lion in Book 3. Type error. Argument of type book is not iterable. We will define dunder contains. Besides self, we will pass in a keyword that we're searching for. I will return, then we'll use the in membership operator, is our keyword in self.title. I'm looking for the word lion. That's going to return true if lion is in the title of this book. Or is our keyword in self.author. Maybe we're searching for an author. Let's try that again. That returns true. Lion is in Book 3. However, lion is not within Book 1. That's false. Is rolling in Book 2. That's the author. That is true. Is rolling in Book 3. That is false. That is dunder contains. We are searching for a keyword in an object. Now, we could search for a key given an object. For Book 1, we'll use the index operator and look up an attribute. Let's get the title of Book 1. The default behavior is that we get a type error. Book object is not subscriptable. So to customize this behavior, we will use dunder get item. Besides self, we have one parameter of key. We're accessing book attributes by indexing. With this object, return the value at this key. What's that attribute? We will check if our key that we receive is equal to title, which it is in this case. We will return self.title. What's the title of the book? So that would give me The Hobbit. Here's Book 2 and Book 3. What if the key is author? None. We didn't set that up yet. If key is equal to author, then return self.author. The author of Book 3 is C.S. Lewis. 2 is J.K. Rowling. Book 1 is J.R.R. Tolkien. What about number of pages? Num pages. Well, we're not set up for that yet. I'm going to turn this into an else if statement. Else if key is equal to num pages, then we will return self.num pages. The number of pages in book 1 is 310, book 2 is 223, book 3 is 172. What if there is no key? Otherwise, if there is no matching key, I'll add an else statement. Let's return an f string key placeholder. Our key that we pass in as an argument was not found. What do books not have? Well, they don't have audio, I guess, unless it's an audio book. Is there a key of audio in book 3? There is not. Key audio was not found. And I'll place that within single quotes. Much better. Alright everybody, so those are magic methods, also known as dunder methods, meaning double underscore. They are automatically called by many of Python's built-in operations. They allow developers to define or customize the behavior of objects when we use those built-in operations. And well everybody, those are magic methods in Python.